Hello everyone, welcome to a new lecture in the series of AI using Python. In this lecture, we will be discussing dimensionality reduction. So far in this lecture series, we were discussing various supervised learning algorithms for regression and classification. From this lecture onwards, we will be moving on to unsupervised learning algorithms. And in this particular lecture, we will be giving a brief introduction to dimensionality reduction, which comes under unsupervised learning. In general, real-world high-dimensional data is likely to concentrate in the vicinity of lower-dimensional manifolds. This is also known as unsupervised learning hypothesis and resulted in the subfield of unsupervised learning known as dimensionality reduction. The two major problems of interest in dimensionality reduction are feature extraction, where the objective is to learn or extract lower dimensional features from the high dimensional dataset, and model extraction, which deals with identifying the relationships amongst the input variables from an unlabeled dataset. Here we will be mostly focusing on feature extraction aspect, and the two of the major algorithms in this category are principal component analysis, which is a linear dimensionality reduction method, and autoencoder, which is nonlinear dimensionality reduction method. In the next two lectures, we will be discussing PCA and autoencoder respectively. Here we will be generating the data set which will be later used for dimensionality reduction. So here we are considering a data set which consists of 100 samples and 10 variables. And we will generate the data set in such a way that there are some linear and nonlinear relationships amongst the variables in the data set. Here the first four variables are defined as completely random, which are considered as the independent variable. And then the next four variables will be defined by using linear relationships as here. And the last two variables are defined using some nonlinear relationships. Now the training data is defined by stacking all these variables. In this case, our XTR will consist of 100 samples of 10 variables, out of which we have 6 relationships across the data. Now the linear and nonlinear relationships in the data can also be observed by plotting this data set. So here x of 2 in Python means like the third column, which we can consider as x3. So we have x7 equal to 2x3, and similarly x8 equal to 0.7 times x5 plus 0.3 times x6 plus noise. Therefore, if you plot x3 versus x7, we will be having a linear relationship as shown here. If we plot x5, x6 versus x8, we can again see a linear pattern. And similarly, if we see x10, x10 is equal to cos of x7 plus noise. Therefore, if we are plotting x10 versus x7, we can see a sinusoidal curve. And also we can use the pair plot function, which can be used for all the pairwise relationships in the data. So here using the pair plot function from the SNS library to see the pairwise relationships in the data. And here we can see that the pairwise relationships, where we can see a linear relationships between x2 and x7, and a sinusoidal relationships between x7 and x10. And here if we see this kind of a pattern, we can say that the variables are uncorrelated. Now if there are many linear relationships in the data, we can use linear dimensionality reduction method such as PCA for reducing the number of variables, where we can extract only the key features in the data which can represent the entire variability. This we will explore in the next lecture. That leads to the end of this lecture. Thanks for watching.